Welcome to the Logarithms video. If you've looked at the list of topics you have to cover over the course of the year, you probably noticed that logarithms isn't one of them. It doesn't appear under the list of P1 topics, and neither does it appear under the list of Paper 2 topics. So why am I teaching you an extra topic, so to speak? Well, you definitely cover logarithms at some point during the year, but just as a subsection of the functions topic. And that's how it will fit into the whole curriculum. But all in all, it'll be an entirely new thing for you, and I think it deserves some special attention. Because from what I've heard from friends and other people at university who've already done and passed their grade 12 maths, many of who actually did really well, they found the way logarithms was introduced in the syllabus kind of stressful, since it's just taught as a small component of the function section, but in all honesty, it's a whole big new thing in itself. And they wish, when they were first introduced to it during the year, more time had been allocated towards studying and practicing logs so they could get used to it and make sense of it. I actually found this quite strange compared to the way it was tackled in the high school syllabus I did, where we were actually introduced to logs much earlier on in like grade 9 or 10. So by the time we saw it as part of the function section, we were completely comfortable with using logs and manipulating logs, and they weren't at all a problem. So, to summarize, I think it's worth giving some special attention to learning and practicing logarithms at an early point, because if you're a student currently doing grade 12 in school, or say even just someone studying individually for the exam, covering it in this manner will definitely give you an advantage over most other students who'd only see it for the first time when working on functions in class. Or even if, say, you're working on functions in school and are just seeing logs now for the first time and would like some good practice with them, this section will come of use to you. So firstly, what are logarithms? Logarithms, or logs which I'll sometimes call them, are related to exponents, which you've learnt about previously and know how to work with. This is the definition of a logarithm. The basic idea is that the log of a number, a in this case, is the exponent to which a base must be raised to equal the number a. So the way this log term is read is log a base b. So its main use is that you can make x the subject of this formula, which is useful if you want to determine what exponent you need to raise a number to get another number. For example, given what we've learned in previous grades, we can do simple basic exponents such as, for example, what number do you need to raise 10 to get 100? Where x is obviously 2, because we know 10 squared is going to be equal to 100. Therefore, x is equal to 2. Or say, what number must you raise 2 to get 0.125? 0.125 is the same as 1 over 8, which is just 1 over 2 cubed. Therefore, x is equal to -3. But then, what if we asked, what exponent must you raise 10 to get a value of 50? So instinctively, we know that 10 to the power of 1 is 10, and 10 to the power of 2 is 100. So to get 50, the value of x is probably somewhere between 1 and 2, since 50 is between 10 and 100. But we don't yet know how to determine the value of x in this case, and that is where logs come in. Let's apply this logarithm definition to the case. So we have a equals to b to the power of x, where in our case a would be 50 and b would be 10. Then if we rearrange this to the logarithm form, we get log 50 base 10. You should keep this terminology in mind, that the base is a smaller number in the middle, which was also the base in the exponent form. And that's why the letter b was used for it. And the bigger number to the right is just the answer a, which you had for the exponent form, which when you rearrange into the log form just equals to the exponent in the exponent form, x standing of course for exponent. Now, to actually get a number from this, you need to know a rule related to logs. So there's a bunch of rules we'll cover, all of which are related to the manipulation of logs. The first of these we'll call rule 1, and to put it simply, log a base b is the same as saying log a over log b. A useful way to know which one goes to the bottom and which one goes to the top is to link it through the fact that you know the smaller number in the middle is the base, which begins with B. So this goes to the bottom, which also begins with B. A, which means answer, goes above, which also starts with A. How nice is that? Let's apply this to the example we're just looking at. X equals to log 50 base 10, meaning log 50 over log 10. Now we finally have something we can type into our calculator. You should have a log button on it somewhere. Then you just set up a fraction and put the numerator as log 50 and the denominator as log 10. And you get the value as 1.69897, and it goes on. But to 3 decimal places, we get it as 1.699. Then you can just confirm whether it's right by calculating 10 to the power of 1.699. For which you'll get a value like 50.00345 yada yada, which is very close to 50, so we know it's correct. I realize some of you may have a button on your calculator which allows you to just input logarithms straight in this form, in which case, great, you could have just calculated it straight. But some calculators don't have that option, in which case the only way for you to calculate it would be using the whole log 50 over log 10 manipulation. And even if you do have the convenient button, it's still important to know this manipulation. Now I'll work through a similar example, then I'll give you a bunch of questions to solve by yourself, and I'll show the answers slightly later on. In this example, 7 to the power of x equals to 4, and we need to find the value of x. A key difference between this and the previous example is that in the previous example, we were finding out what exponent we would need to raise 10 to get a value of 50, meaning a number bigger than 10. But this time, we're finding the exponent we need to raise our base 7 to get a value of 4, meaning a number smaller than 7. But this doesn't create any new problem. You solve it exactly the same as before. First, you change it to logarithm form. Then you apply the first rule, giving you log 4 over log 7, which comes to a value of 0.712. Then you just check this on your calculator and you'll see a value of 3.99677 on and on, which is basically 4. Now here's some questions for extra practice. I'll write the question, then you should pause and try work on it, then I'll write the answer. For the first question, we have 0.1 to the power of a is equal to 2. So what is a? Pause and try it out. And a is negative 0.301. Next, we have 9 to the power of z is equal to 111. So what is z? Z is 2.143. Then lastly, we have 12 equals to 1.2 to the power of capital B. So what is capital B? B is 13.629. Now let's look at the second logarithm manipulation rule. The next part may be a bit heavy, so just be ready. If you have a logarithm with an exponent in it, you can take the exponent down and put it in front of the log as if multiplying the log by it. You may be wondering, how did we end up with a log term having an exponent in it? Didn't we do the whole log thing to make the exponent the subject in the first place? So you'd end up with this sort of log if your original form was something like the following. A to the power of x equals to b to the power of y. A useful way to visualize it is by representing this whole a to the power of x term as just a simple variable, let's say v. Then just substitute it back into this equation. Then it should now be easier to change it to logarithm form, which gives you y equals to log v base b. Then you substitute the definition of v back into this and you get log a to the power of x base b. And that's how you end up with this guy in the first place. Then we just apply root 2 to it, which allows us to bring the x down here, giving us y equals to x times log a base b. I'll show this process in a few more examples, but I'd just like to address one last thing about this form. The way we converted it to log form in this example was by making y the subject. Another way you could have done this is by making x the subject, in which case a becomes the base of the logarithm and b to the power of y goes up here. Then you could just apply rule 2 to it and you could bring y down in front of the log, giving you x is equal to y times log b base a. I showed you this other possibility just to give you a better idea of how logs can be manipulated. Anyway, it'll become a bit clearer after we cover a few other examples. For the first question, we have m to the power of v equals to n to the power of w. So we need to make v as the subject. Pause and try it out. So v equals to w times log n base m. Then for a different spin on the question, try to make w the subject. And we get w as v times log m base n. Next we have capital A to the power of b equals to 20 to the power of c. And we need to make b the subject. There's one new aspect in this example, and that is we now actually have one number in it instead of just having letters. But the working stays exactly the same. Pause and try it out. So b equals to c times log 20 base a. Then try to make c the subject. So c equals to b times log a base 20. Lastly, we have 7 to the power of x equals to h to the power of 15. This question now has two numbers, but the working still stays exactly the same. Pause and try it out. So x equals to 15 times log h base 7. Then try to make 15 the subject. You get 15 equals to x log 7 base h. Now let's look at the third logarithm rule. So what it says is that the log of a number x times a number y with a base b is equal to the log of x base b plus the log of y base b. Meaning that you can separate this product of terms into the sum of one term and the other, but while keeping the same base for both log terms. Let's look at some examples. We need to apply rule 3 to the following examples and simplify them. First, we have log 5 times 2 base a, and using rule 3 we can just separate this into log 5 base a plus log 2 base a. Next we have log a times b base 7, which we just simply separate into log a base 7 plus log b base 7. Next is log 18 base 2, and we need to simplify this using rule 3. There's many ways you can do this, but we'll just look at two simple ones. The first step you need to do is you need to represent 18 as a product of two values. One option is 2 times 9, which breaks down to log 2 base 2 plus log 9 base 2. Another way we can get the value of 18 is by multiplying 3 and 6, which breaks down to log 3 base 2 plus log 6 base 2. For the next example, let's look at it from the opposite direction. Here we're adding together log 4 base 3 and log 5 base 3. So we know the resulting term would be a log with the same base as both terms. So log 3, and the term at the top here would just be 4 times 5, which is just 20. So we would get log 20 base 3 as the answer. Next we have log 6 base 5 plus log 8 base 3. Now can we add these together? Nope. And that's because they have different bases. 5 for the first one and 3 for the second. So we can't further simplify it. For the second last example we have log 4 plus 3 base 6. So that's simple, right? We can just split it to log 4 base 6 plus log 3 base 6. Nope. Remember, you can only split it this way if the terms in the brackets are multiplying each other. However, in this case, this guy would just simplify to log 7 base 6. For the last example, we have log 9 base 5 plus log 6 base 5 plus log 7 base 5. So firstly, can we apply the same rule when you have 3 terms instead of 2 like we've had so far? Absolutely. Just first thing to make sure before doing this is to check whether all 3 terms have the same base, which in this case they do. Therefore we can combine them using rule 3, which gives us log 9 times 6 times 7 base 5, which is log 378 base 5. Lastly, here's 2 questions for you to practice by yourself. Here's the first question. What does it simplify to? Pause and try it out, then I'll give you the answer. You get log 30x base 12. And the second question is log 20 base 3 plus log 3 base 20. And what does this simplify to? Nothing happens here, since the bases are different. So we're almost at the end. There's just one more rule you need to learn. But before that, there's some properties of logarithms which you should know about. Now technically, I should have shown these to you before going through the 3 rules I just covered, but I figured it'd probably be better to give you some practice with logs before just blasting you with a bunch of information. The first of these is regarding the range of values you can actually take the log of. First and foremost, you can only take the log of positive numbers, meaning x needs to be more than 0. So you can't have a logarithm of a negative value or of 0. If you type this into your calculator, you'll just end up getting an error because these values don't actually exist. Next, if you take the log of a number between 0 and 1, the result will always be a negative number. For example, the log of 0.3 is negative 0.523, and the log of 0.9 is negative 0.046. And the last thing regarding the numbers you can take a log of is, if you do the log of 1, the answer will always be 0. So log 1 always equal to 0. The second property you need to learn is log x base x is equal to 1. Meaning that when you take the log of a number, you have the same number as the base, then the overall logarithm will equal to 1. And this would apply to any number as long as it's greater than 0, meaning it needs to first conform to this rule, and as long as it's more than 0, then this will be true. For example, if you try the number 4, log 4 base 4 is equal to 1. Or even if you try something bigger, like say 200, this will also be equal to 1. It's kind of interesting. This actually comes as a result of rule 1, which we looked at before. I'll bring it up again just as a reminder. Then the idea is, if you took the log of b with base b, you would have log b over log b, and any number divided by itself is just 1. Finally, let's look at rule 4. What this says is that the log of a number x divided by y with a base b is equal to log of numerator, which is x in this case, minus log of the denominator, which is y in this case, both with original base b. This is a very similar idea to rule 3, except it's sort of the opposite case where this time you're dividing one term by the other and you're subtracting one from the other. Let's look at some examples. We need to simplify the following using rule 4. First, we need to simplify log 40 over 4 base a. Now obviously we know 40 over 4 is just 10, but we've been instructed to simplify this using rule 4, which will just give us log 40 base a minus log 4 base a. Next, we need to simplify log m over n base 5, which would just be log m base 5 minus log n base 5. For the next example, we're looking at it from the opposite direction, meaning this way, going back, and we have log x base 12 minus log 5 base 12. And since the bases are the same, we know we can use rule 4 on it. And when you do that, you just get log x over 5 base 12. For the last example, log 10 minus 3 base 6, which you should know we can't simplify using rule 4 into log 10 base 6 minus log 3 base 6, because the terms in the brackets need to be one divided by the other. So this would just simplify to log 7 base 6. And with that, we've covered all the properties and rules related to logarithms that you need to know. I actually went a little bit beyond how much you need to know for your exam, but trust me, since we've covered it at such a high level, any logarithm question you encounter now under functions or other topics will just be a piece of cake. Before I summarize what we covered in this video, here's a final question for you to practice by yourself. It will require you to use the various different rules and properties we covered in this video to arrive at the final answer. And I think if you can solve this, then you're quite on point with logarithms. Here's the question. So using whatever you know, simplify the expression log 90 base 3 minus log 5 base 3 minus log 2 base 3 as much as possible. Pause and try it out. And the final answer you get is a value of 2. If you've done some simplification and still have an answer with some logs in it, pause and play around with it a bit to see if you can get a value of 2. If not, here's the full working. You can go through this yourself. I'll now just summarize what we've covered in the logarithms video. To summarize, logarithms are a different way of expressing exponent terms, which allows you to make the exponent as a subject and solve for it. So for an answer A, which equals a base b raised to an exponent x, when converted to the logarithm form, it makes x into the subject, which will be equal to the log of a with the base b. Next thing to know is there's some restrictions on the values of a and b that can be represented using logs. The main one of these is that both a and b must be greater than 0. So you can't have a log of a negative number or of 0. In addition, the value of the base b in this form cannot be 1 because log 1 is equal to 0. And that's a problem because slightly further down we have rule 1, which shows that this logarithm form can be represented as log a over log of base b, which is the number in the middle. So if b is equal to 1, you'll be dividing by log b, meaning log 1, which is 0. And we know we can't divide a number by 0. And also, if you take a log of a number and you have the same number as the base, this will always equal to 1. And last thing related to log values is that if you take the log of a value between 0 and 1, so meaning a fraction, this will always equal a negative value. Then there's 4 rules related to the manipulation of logs that we looked at. The first is the log of a term a with a base b is equal to the log of a over the log of b. Next, when you have the log of a term with an exponent, such as a to the power of x, you can bring down the exponent in front of the log term as if multiplying it. And the third rule is if you have the log of 2 terms multiplying each other, such as x and y in this case, this is the same as saying the log of one term plus the log of the other term, while keeping the same original base for both terms. And lastly, the fourth rule is if you have the log of one term divided by another term, this is the same as saying the log of the numerator minus the log of the denominator while keeping the same base.